Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to IE 206 Engineering Economy. This is part 2 of chapter 5, the present worth analysis. We have talked about the present worth analysis techniques in the previous video, and today inshallah we will continue with the new techniques that related to the present worth, which is the capitalized cost and the payback period. Cost is the technique that we will use it in both chapter 5 and 6 in the present worth and the annual worth analysis, and we will see in a few why it is common between those two chapters. First, let's go with the definition and explain the definition. What does the capitalized cost mean? The capitalized cost is the present worth of a project that lasts forever. So if I ask you to give me an example from real life about a project that you have seen it that lasts forever, what you suggest or what you can tell that related to the projects that last forever. If you want to participate by mic or writing in the chat box, think about a project that lasts forever. Okay, any ideas? Constructing schools, tunnel, yes. Constructing schools, I would say um, maintaining school, yes, but constructing school, maybe not, because it is ended project at the end. But maintaining government schools, yes, it is lasts forever because you always need to maintain it, clean it, and maintaining the conditioning and so on. Tunnel again, building the tunnel is different than maintaining the tunnel. If you mean by maintaining the tunnel, as Hazem suggested, yes. Also, if you have traveled using highways, yes. Sorry for the voice. Let's go back. The constructed projects usually end by the end of the construction, but the maintenance, like if you have traveled from city to city or region to region, you always use a highway. You see sometimes a sign on the highway that tells you this is a contract number and for maintaining this highway or this road. And this what we mean by, this is one of the example for a project that lasts forever, because maintaining this highway, it is going to be over and over. You never can stop maintaining those highways or roads or even school, that as the students here suggested, otherwise it will not be operated effectively. um, it doesn't have to be all. There is a student asking, Faris, all maintaining processes. It doesn't have to be all the maintaining processes, because some maintaining processes end by a certain number of years, like your car. If you consider your car, maintaining process lasts forever. No, because there is a lifespan for that car, and maintaining those cars, it will not last forever. At the end of the life span of that car, you need to replace it. But for those construction, it can be rebuilt, it can be maintained forever. um, if you are considering that the maintenance process, is it applicable or no for all the types? We cannot say it's for all type of projects, but it is lean toward maintenance than constructions. Does that include sustainable energy? Okay, it's a good question. Um, Sustainable energy, when we talk about um, the maintenance for the sustainable energy or operation, it could be yes, but also you have to consider things that need to be replaced after a certain time. For example, the battery capacitors for the solar cells maybe a certain time need to be replaced, but for the contract for maintaining this whole units of solar cells or any other examples of alternative energies, yes, we can do that. We can consider maintaining that is going to last forever, but some of those items or devices need to be replaced after a certain time. But the maintenance, if it's including that, then it's okay. If the maintenance contract it was not including that, then we have to exclude the things that not going to be undercovered in the maintenance contract. When I mention highway, because the highway you usually you do um, the pavement, reinstalling the pavement or the اللي هو MC1 material اللي هي we call it the asphalt. Uh, this material, it is always vanish over time, or let's say it turned away after using that highway for a certain number of years. So you need to reinstall it again. But you're not going to, for example, you're going to take that one and you're going to sell it or you're going to get out of it, but you just reinstall it again to refresh the highway or the road. So the idea of the projects that last forever, I think now it is close to your mind. These projects are not going to be for a certain number of years and then you are going to stop that project. Like building maybe skyscraper or large buildings. It may take long time, like Al-Haram construction project in Mecca. We have seen it. It has been there for decades because there is always expansions going. After the finish phase, they start another one. But we cannot say this is a capitalized cost project because when you finish the first phase is going to be done and then you start another project with a different cost. But maybe we can consider, yes, maintaining the haram in terms of the carpets cleaning, floor now sanitizing, and so on, changing cover of al-Ka'b. This is for forever. It's not going to stop. يعني as long there is يعني al-Haramis exist, so those things has to be maintained. You can now tell how is the capitalized cost project compared to another projects that are end up with a certain time. Okay, is it clear now the concept of capitalized cost? I'm telling, I maybe spend time on explaining examples because I want you to get familiar why we are doing this technique, because these type of projects is different than the one we have applied in the previous part. That's why I intentionally did that to start this presentation or this part of this chapter in a separate video, so you can relate how they are different between each other. The infinite analysis period is n in the problem is very long. You that consider infinity because it is يعني over maybe decades of years. Okay. The formula that we are going to use is different than the one we have used in the previous part of chapter 5. The easiest way to recall this formula, I call it pi, related to pi, either اللي هو الفطيرة if you are hungry or pi related to the pi اللي هي in the mathematics symbol. So if you are not hungry, you can relate it to the simple mathematics that we all know, 3.14, I believe. And uh, how we get that pi is A, the annual, is equal P multiplied with I, and that is the pi. So now we see the common between the annual and the present here in this formula, and that formula exactly we are going to use it again as is in chapter 6. So recalling this formula because now we want to find the present. In chapter 6 we are going to use it to find the annual. So memorizing this formula is going to be easy for you because you are going to apply it twice in this course. And what about the table? Maybe some students will say, okay, what about the tables that we used to do? We used to do find the annual or the present, in this case in chapter 5, by, let me open the pointer so you can see where I am. Yes, I'm pointing here to the red font, the red line, where is the example, the present equal annual multiplied with P given A to I, which is the interest, and N. And in this case, we agreed all that the N is going to be infinity. Okay, maybe someone will say, okay, what about the tables in this case? Okay, some tables, I will show you here one example of the tables that consider actually the infinity life cycle, as we will see now. Let me zoom in. If you open that file which you have on the Edmodo and you go all the way to the end of that table, I don't know if you can see that, but you can tell after the 480 years, or the n equal 480, regardless if it's years or month, we can see that there's an infinity, n equal infinity, okay? And in this case, when you want to find P given A or A given P, which is the one that related to chapter 5 and 6, you can find them here. It's given. Okay? Is it clear? Okay. So if you are to use the tables, some tables consider really the n equal infinity, but some other tables, they don't. Okay, maybe the question then, what I'm going to do if I have a question that is including capitalized cost concept? I'm going to use the tables or I'm going to use the formula? Well, both of them are correct. يعني fortunate that both of them is correct, but I advise you to use the formula because the percentages that we may use in the question that are not shown in the table. So maybe if you are going to rely on the table, you will not find the exact interest rate. So the formula is very easy, that one of those, it has to be given. I mean, two of them, it has to be given. Obviously, the interest would be one of them, but either the present or the annual is given. So just it's a matter of multiplication. So I think it will save you steps going to the tables and finding the interest and then finding the n equal infinity and finding the value. I think is just multiplication. It will make it easier for you. So I advise to use the formula. But if you find the interest rate on the table and you want to use the value, there is nothing wrong with that also, okay? So till here, I think we are clear. So let's take a very simple example about a capitalized cost. Um, an example says, in order to be able to withdraw 50,000 per year forever at I equal 10% per year, the amount of capital required is 50,000 divided by zero point 0.1 equal 500,000. What does that mean? Okay, the withdraw, we all agreed that it's and per year, we agree that since it says per year, that's mean it's an annual. and the interest is given 10%, and he wants to find the capital. If you recall previously, we have mentioned that first cost, initial cost, capital cost, all of those are meaning the same, present. Okay, so when it says the amount of present or amount of capital or amount of initial cost, they are all referred to P. Okay, and to find P, and you have already the annual, you just divide the annual, which is the 50,000, by I, and here pay attention, we are using the ratio, not the percentage. Okay, we are using the ratio, and the ratio for the 10% is 0.1, obviously. Okay, so pay attention to that, because some students do mistakes here and use the percentage, which is the 10 as is, without considering the ratio. Okay, so that is the 500,000 is the present for that annual for infinity number of years, and the interest rate is 10%. How did we know that it is going to be for infinity? Where was the key word in this example says this is an capitalized cost and not regular present given annual? أحسنت يا حازم. ممتاز يا عمر. Excellent. This is what I want you to pay attention, and I meant that I don't emphasize on that word because I want you to catch it. When it says forever here, when it says 50,000 per year forever, this is a key word for you that is related to capitalized cost. You will hear this word always in the related problems for the capitalized cost. When it says forever, thereafter. Okay, so pay attention to those, and also it didn't mention any number of years here, so this is one of the things. But you will see some examples, it mentioned number of years n, but then it mentions some other values in the cash flow, okay, or in the problem, that is last forever. Okay, so you have to find these keywords which will tell you that it's a capitalized cost, and it is easy to find them. It's not something that hidden. But as I said earlier in this course from the first meeting, it needs a good communication skills to extract the information and the required information so you can solve the problem correctly. Okay, so let's move on with another which is related to the capitalized cost, but something called by the way, capitalized cost, the abbreviation of capitalized cost, we call it CC. Okay, C for capitalized, and the other C is for the cost. Recurring and non-recurring. What does that mean, recurring and non-recurring? The recurring is a periodic and repeat cost. Non-recurring, it is one time. We will see an example now in the next slide. But how you solve the non-recurring? We solve the non-recurring as usual. You just convert the future value or the one single payment to any other value that, or any other form of time format. But for the recurring, we will see another next in slide an example for the recurring, and we will see how we follow those explanation here, how to solve them. Okay, there is a question, Saleh. Yes, before we move on.
دكتور لما نشوف كلمة per year forever في السؤال أعرف إنها capitalized cost على طول صح؟
Yes, one of the word is forever. We will see another examples.
بس forever كده.
Yeah, I mean any other synonyms related to the same meaning as here in this example. It says, let me zoom in here. A government project has initial cost 100. Pay attention. Initial cost, first cost, capital cost. Okay. اللي هو يعني رأس المال start with this project. Okay. 150,000 and maintenance cost of $5,000 throughout its life. And this is answering Saleh question. It doesn't have to be forever. This is another explanation for forever, but in a different way. Throughout its life, that mean is going to be forever also, since it didn't say in the question its life it is 10 years. It didn't say that, because the next sentence says calculate the annual cost. خلاص, it's already all the given information about the life, it was over here. Calculate the annual cost amount assuming 5% interest rate. 5% interest rate. And ask you to find the annual. Okay, pay attention, didn't ask you to find the present. Actually, this example, it is falling under chapter 6, but the author show it here in chapter 5 because it is going to tell you that both they work together. Chapter 5 and 6, they are, I mean, two faces for the same coin, we can tell, or we can say that. The first part of this question says the present worth, we have to find it, which is the capitalized cost, and then we can find the annual, because the initial cost, which is the 150,000, okay, and then we have the 5,000, which is annual, and we have to find the present for those two values. We have the 150,000, and we have to convert the 5,000 to present so we can find them all together at time equals 0. And pay attention, this 5,000 is last forever. So the 150,000, there is no need to change it because it's already on time 0. But the 5,000 we converted using the capitalized cost formula, which is P equal A divided by I, and the A here is 5,000 divided by R, which is the 0.05, the ratio, and that is equal the quarter of the million here, and that is the present for the whole values in this cash flow. Now to find the annual, out of this 250,000, which is the summation of all these values, to convert it, we use the same formula. So we here use the formula for the present first, the first step, to convert all these values to present, and then to find the annual forever for that project. And to convert it to annual, we use the same formula, which is A equal pi. Pi here, where is the CC, which is the capitalized cost, or you can tell it's the present, okay? Multiplied with the I, the 250,000, multiplied with the 0.05, and that is the 2,500 is the annual for all these values per year forever. Okay. طيب. Okay, so far, let's move on to the next example, and we add more complexity to this concept. Here is I like this example, and I really advise students to read this example carefully and try to solve it without looking to the answer, because looking to the solution, it will show it that it's very easy, but when you try to solve it, or you have it in exam or homework or quiz, you struggle a little bit. And I will explain where is the part where is most students they make mistake, and pay attention to that part, highlight it and read it carefully at home. Okay, so someone can participate in reading the question. Anyone? تفضل يا عمر. Thank you.
الصوت واضح؟
أيوة, yes, clear.
The system has an installed cost of $150,000 and an additional cost of $50,000 after 10 years. The annual software maintenance contract cost is $5,000 for the first 4 years, and $8,000 thereafter. In addition, there is accepted to be a recurring major upgrade cost of $15,000 every 13 years. Assume that I 5% per year for county funds.
Okay, thank you, Umar. جزاك الله خير. I like this example. يعني, if we think about capitalized cost problems in exams, it cannot go further complex than this one. It can go around this one, but this is, I believe, it is one of the good examples that shows all the techniques in the capitalized cost together for recurring, non-recurring, which I will explain now. What does mean the recurring here? And show you that in a good example that sum them all. Okay, let's take it one by one. First, that we have agreed first cost, initial cost, capitalized cost. You can add to the list installed cost. When it says installed cost, this is definitely cost that you put it or you pay it at the beginning, because the installation, it is usually at the beginning of the project or at the purchase. So the initial cost or the installed cost, the 150,000 which was given, يعني obviously, I think it was something that obvious. It is already on time 0. Then there is an additional cost, 50,000, after 10 years. يعني you can consider that it is another payment installment, دفعة متأخرة after 10 years, and it is placed on the cash flow, as you can see here in year number 10 as an outflow. And then now it says there is an annual operating cost, which is maintenance cost, $5,000 for the first 4 years, and then $8 thereafter. So the first 4 years, you see the outflow, there is a 5,000, and then from year 5, and pay attention to thereafter here, okay? When it says thereafter, that's mean it's year 5 until infinity, there is 8,000. In addition, there is expected to be recurring major upgrade cost. Here is the first time we see recurring. By the way, it doesn't, and pay attention here and write this note, it doesn't have to tell you that there is a recurring. But the concept of the recurring, we will explain it now when we explain the 15,000 that comes every 13 years. So here it says and underline there is a recurring, okay? But if you read this sentence, there is expected to be, okay, a cancel recurring, to be a major upgrade cost of a 15,000 every 13 years, then this is a recurring without telling me. The word recurring here does not add anything. Why? Because that 15,000 is every 13 years and didn't say that it is only for 20 years or 25 years. It is for infinity. So what is recurring actually? And why this 15,000 we call it recurring? The 15,000, it is appear every 13 years, okay? And it is last forever. It means at year 26, it will appear again, okay? And if you add another 13 years, how much will be that the end? It will also appear again, and so on. So the recurring, it is a periodic payment or periodic value in the cash flow that repeated over and over and over for infinity. It is, again, it is a periodic value that appear in the cash flow that repeated over and over for infinity. And in this case, it is repeated every 13 years for infinity. Now, do you understand what is the recurring? Give me thumbs up or give me okay. Good. Excellent. Okay, ممتاز. Now, assume that it is 5% per year for the country funds. Okay. Now, what is the requested here in this question? In part A, ask you to find the present worth equivalent. When it says the present worth equivalent, that means all these values given in this question need to be converted to present. And in part B, it says the annual cost amount. So all these values need to be converted to annual. If you find the annual by the formula for the capitalized cost, easy to convert it to present because it's one step, and vice versa if you want to find the present from the annual. But again, where was the keyword that tells us this question? It is capitalized cost and is not a regular chapter 5 problem. Thereafter, أحسنت يا عمر, الله يفتح عليك. Thereafter, when it's thereafter, خلاص يعني إيش? You see in Disney movies sometimes they say they lived happily ever after. فخلاص يقول لك يعني إيش? They lived together for their life يعني for infinity. So thereafter, okay, this is a keyword. So you have to pay attention and read the question that where was the keyword that tells it is infinity. Now let's take it one by one. So don't panic when you see yes any words that's synonym to infinity. Okay, let's take it one by one, how we convert them to present. So what about the 150,000? How we convert it to present? Yes, Abdullah.
هي أساسا في البريزم.
Yes, Ahsan. Thank you, Abdullah. Okay, I want you just to check if you are up, all of you. Or, okay, yes, 150,000 is already present. No need to convert it because it is installed cost. And by the way, the cash flow, it doesn't have to be given. Actually, it's not going to be given in the exam. So this is not because you see the problem here, visualize clearly. You are to expect to have text problem without a cash flow. The cash flow is now part of the solution here, okay? Is not part of the problem. طيب. Now the 5,000 that after 10 years, 50,000 after 10 years, to convert it to present, this is regular as what we used to do in chapter 2 even, not chapter 5. It is a future value. We want to find it. لا يا فيصل, not 4 years. Now we're talking about the 50,000 that placed on year number 10. It is a future value placed on year 10 and you want to find it at year 0. So what is the formulation for that? Someone write me the formulation for the 50,000 to convert it to present. P given F for 10 years multiplied with the 50,000. أحسنت فيصل, رحيلي, محمد, عبد الغني, حازم, حربي, عبد الله الصاعدي, فيصل, رحيلي. Yes, all of you. Thank you. Yes. That's correct. Okay. Moving on. Now, all of these, you are adding them up by a minus sign. Why minus sign? Because they are, yes, because they are cost. They are not revenue. They are cost. So you have to add them with a minus sign. Good. Now, what about the 5,000 for the first 4 years? The 5,000, it is annual, but is not for infinity. It is only for the first 4 years. Okay? It is not for infinity. It is for the first 4 years. So the 5,000 to convert it to present for 4 years, what is the formulation? PA. Okay, continue. PA for 4 years. Faisal now ظبطها. Okay. PA 4 years multiplied with the 5,000, and the I, forget that the I is 5%. Okay, so 5,000 multiplied with the P given A for 4 years for 5%, which is found to be here. Okay, where is the P given A? Yeah, sorry, it is here, the first one. Okay, now what about 8,000? The 8,000, it is annual for infinity, but is not starting from year 1. It is starting from year 5, because when it says here in the sentence 5,000 for the first 4 years and 8,000 thereafter. Thereafter means from year 5 until infinity. So the 8,000 from year 5, you see in the cash flow, until infinity. Okay, converting that will take 2 steps to find it. And what we do in this case, we divide the 8,000 over the interest to find what? When we go to the formula, if we divide the annual by I, what we get? We get the present. Okay, now here is the question. Wait, Abdul Karim, please. Until we finish, I will take your question. When we find the present, now here is the question, pay attention. The 8,000, it is annual for infinity. We divide it by I, which is 0.05. When we find the present, is the present located at year 4 or at year 0? 4. أحسنت يا عبد الله. Why? Why it is located? All of you, Faris, Hazim, Muhammad. Why? We said there is a rule. Recall when we said in chapter 2, أيوة يا عبد الكريم أحسنت الله يفتح عليك. If that was your participation, you wanted to say, okay, thank you, but I thought maybe you have a question. Now Abdul Karim says, because we have learned in chapter 2 a rule related to the annual and present. Even in the capitalized cost, we don't break it. If we want to find the present from annual, we just go 1 year back. That means all these 8,000, when they are going to be converted to present, they will be placed on year 4. Great. Now, after it's placed on year 4, it is a single value. It is easy now to move it to year 0 by using which formulation? Someone type the formulation. P given F. ممتاز. For how many years? 4. Yes. And that's what you see it in this bracket. The 8,000 divided by 0.05 to find the equivalent of that annual at year 4 as a present year. Okay? And then multiply it with the P given F for 5% for 4 years to move it from year 4 to year 0. Okay, great. Now we come to the tricky part. This is where is the recurring part. And now take a deep breath and pay attention and focus with me, please. The 15,000, this is applied every 13 years. It's a single value, but it's applied every 13 years. The rule number 1 in the recurring, what we do, write this note, highlight it, okay? We deal with the first one only. We neglect the remaining. We are not neglecting, but in mathematical formulation, we are not considering them, but we are considering them in the concept, and I will explain that why. But in terms, when you see the recurring, all what you have to do, think about this one here, the first one, where it was placed on year 13. So focus on this one, and you will solve this one and for all the other 15,000. What we do here, what we do is we deal with this 15,000 as a what? As a future value. Isn't it the future compared to the 0? It is already future, and it is placed on year 13. Great. So when we find the annual from this 15 for 13 years, we are finding the value of that 15, the equivalent annual value of the 15 for all those years until here. Okay? Great. Great. So when we find the annual, wait, please just bear with me, Saleh, until I finish, and then I take all the questions. Sorry. So the 15,000, it is a future value, and we want to find the annual from future. So the annual from future for the 13, it will be all this period. How I find the annual? The annual from future is A given F multiplied with the 15,000 with the I equal 5 and N equal 13 because it is placed on 13. Great. When I find the annual, if I have the annual, okay, now that annual, it is exactly going to be the same annual for all the coming future years. Why? Because if you have taken also this one, 15,000, and you want to find the annual for the 15,000 until year number 13, you will do the same formulation, A given F, 5% and 13. So that is the value here you found for the annual is similar to the annual that you found it in this part. As long they are similar, now what we do is we divide it by I to find the present. We do have the formula says if I have the annual, I can divide it by I to find the present. And since the annual I found here, it is going to be similar for all the other 13 years cases, I deal with the first one only, convert it to annual, and that annual is going to be equivalent to all the other annuals coming in the future because they are going to use the same formulation, okay? And after that, I divide it by I to convert it to present. And that's all for the recurring. Before we move to part B, now where was your questions, Salih, or any other students they have questions?
Yeah, just repeat the rule, please. We deal with the first year.
Salih?
Hello.
Yes.
Hello. Just repeat the rule, please.
Repeat the rule.
ايوه اللي قلت عليها انه نتعامل مع اول سنة.
Yes. Okay. Okay. Now in the recurring, well, regardless if it says recurring or no, as long you have a recurring case, which is a periodic value that appear in the cash flow forever, and this periodic repeated after a certain number of years, like the 15,000, appear every 13 years for infinity. So we just focus on the first one. Where is the first one appeared here in this example? It appeared in year number 13. So we don't have to look after that. In solving this problem, just formulate the first one and you will solve the remaining. How I formulate it? This is a future value considered compared to the present. And what do I need to find? in this case, I need to find the annual because it's going to be the one that will help me to find the present in this such case for a capitalized cost. Finding the annual from future is A given F. For how many years? For 13. It will give me all the annual up to here for the 15,000 that appeared on year 13. And the present the present to be found from the annual in the capitalized cost is you divide the annual which you just found by the ratio of the interest rate, which is 0.05. Yes, Alhamdulillah. Nawaf, I think your question now was answered. We are not dividing by average or half, okay? I guess that was before I explained my answer. Now, is it clear? Yes, Nawaf.
دكتور أنا أقصد على السنة 13 قسمنا على نص آخر شيء، هل له دخل في هذا ولا؟
No, this is not نص. This is 0.05, which is I. I
معلش دكتور، معلش لخبطت، معلش.
This bracket اللي هو starting from minus 15k, a given f, 5%, 13. This is to find what? To find the annual for the 15,000. The annual from here until here. When you have the annual, what you need to find the present in the capitalized cost formula, you need the annual. خلاص عندي الانnual, I divided by the interest rate, which is 0.05, I have the present. Okay? Now part B is easy. As long as I have the annual, the present, sorry. To find the annual, you go back again to the formula. To find the annual, A equal pi. Remember pi. Present or capitalized cost multiplied with the I. The capitalized cost, we just found it in part A, multiplied with the 0.05, and that is the annual for all these values in annual format. So I convert all these values to annual for infinity number of years. It would be 17,349 and 85 hundredths. Okay. Is it clear? I hope if you can also watch the video again, it is explained in the lesson. I will upload it on the YouTube just after the lecture by 10 minutes or 15 minutes, so you can watch it later on your free time to repeat the solution over and over to explain, to understand the concept. Now that was for the capitalized cost. We come to the last technique in chapter 5, and is one of the most favorite technique for all students. They like to see it in exams because it's very simple and easy, and it is different than previous techniques. Here we don't find the value of money, we find, as you can see from the title of that section, period. And period means if we are considering the unit of the period, is it going to be dollar or time or interest? Time, yes. So now this is the first time we find time in this course, because we usually change the money over time and we find the value of money over time. But here is the first concept where you find the time. Okay, so the payback period, I need you to understand what is the concept behind the payback period. The payback period, to find the time needed to recover from the initial investment. Again, the time needed to recover from the initial investment, because the initial investment you pay, you don't have profits. صح? You start your business, your project or your company, You are paying, establishing, building, paying salaries for people, hiring. Once you start your business, now you will count how many years you need, or how many months, or how many what time needed to recover my initial investment, okay, that I paid at the beginning. But pay attention to that note. Never use payback analysis as the primary means of making accept reject decision on an alternative. So it is part of the tools that you can rely on, but is not commitment. Okay, so the annual commitment you need before you just consider the payback period as a only option. So in the feasibility study, they show you the set of tools that you need to start your business and make sure that is it this business going to be feasible or no. In the engineering economy, we learn all of them. We know how to use them when we use them. But in the feasibility study course, you collect the tools and the additional tools only to relate to a certain business, that to go with that business or no go. Okay. Not preferred method for final decision. Use only screening tool. That means screening tool يعني تستخدمها but you don't rely only on that one. Read those, because those notes I bring them sometimes in the questions in the exam as a conceptual questions, not meaning that memorizing them but understanding them. Okay. طيب, how we solve the payback period and how the problem looks in the payback period. I focus in this course and at this level on only this type of examples. In the examples for the payback period, I don't go in further details. I need all from you to understand the concept, and understanding the concept requires from you to know that the um, the number of years that represented in the left column, and the cash flow for your business. And then in the cash flow, you look for the net, which is placed here in the yellow cells. You obviously see the first year, which is the year 0, you have minus 30,000 because you just start your business, you don't have any income. But in the coming year, in year number 1, the net start to be reduced, and the loss will be, it was minimized at the end to be 4,000. And on year 2, now you start making profit at your project. So when we say the payback period in this example, it is going to be falling between year 1 and 2. That means this project will take up to, let's say, year and a half or year 0.3 or whatever it's the exact which we will calculate it now, and that will be the time needed for that project to pay back its initial investment. Let's see a solved example. Okay, when you have the tables, don't worry about this column, how it is being founded, because I bring you the column that without a conversion needed. The cumulative, which is here, the cumulative cash flow or the cash flow, I will bring you the final one that not need to be calculated, that only just to use it to find the payback period. And in this example, as you can see, the net start to be changed from loss to profit between the year 3 and year 4. And to find the payback period, basically you do interpolation to find the exact number of year between 3 and 4. I mean the not number of years, the exact period that where is the payback fold between. And to find that is you consider number 3 and 4 as the number of years, and you find the amount of the net for each one. Here it was minus 3,000 and here was 5,000, and use the interpolation we have explained in chapter 2. What is the explanation, interpolation عفوا, and to find the n which is fall between 3 and 4, and in this case it was 3.375 years. What does that number mean? Definitely a question. What students do, I will tell you what the mistakes do. They don't look to the lecture, they don't pay attention to what I just said, and they go waste their time in the book and the slides trying to find how this cumulative cash flow was founded from here. Even though I just mentioned, don't worry about it, because you already covered that technique in other sections in this course, so I'm not going to repeat it here. I consider only focusing on bringing you a ready column. So students, what do? They go and search how this has been calculated. I bring them this column, and they still go find additional column for something that I didn't request, and I said you don't have to do it. And at the end, they find a final answer that is not correct. Other mistakes that appear from students, they find this number correct, they use the formula and everything is correct, but they don't know what does that number mean. So you see the mistakes I've seen over years. I'm telling you those mistakes. So my request is, please pay attention to what I just said and what I just warn you from, so you don't do it in the exams. You need to know that the table will be given to you ready, and you don't have to find any other values other than the payback period and see where is the sign start to flip from minus to plus, and then find from the interpolation that is when was exactly or how long is the period needed to pay back the period. The 0 is exactly where is the payback. The payback is the equilibrium between the cost and the revenue, which is the break-even point. Okay, and when you find the number here, that which is the payback period, you need to make inferences about what does that mean. What it tells me means it takes 3 years and 30 and 3.37 years to pay back the initial investment for this project. You need to understand what does that number mean. I don't really care if you could find it, but you don't know what does it mean, because calculating number doesn't tell anything if you don't know what this number tells you. Okay, so I hope that you understand what is the required from this section and what is needed from you to pay attention on. And I hope I answer also this question from Hazim about this 0, because I said this 0 is the equilibrium point, because the cost here was minus and here was plus, and at this point it was 0, and this is what we wanted to find. When is the payback? لأنه at 0 you pay back all the cost, and now from the next coming days it should be you are having a profit. Okay, take questions يا صالح.
دكتور انه الصف الثالث او الرابع هذا من نفس السؤال صح؟ ممكن تكون اي صف غيره.
What you see here, it is already from the previous table here.
اي فاهم لكن مثلا في اي سؤال غيره يكون اي رقم غيره، مثلا بين 1 و2 او 2 و3.
طبعا definitely yes. But it depends on when was the minus change to plus. Okay, طيب, other questions? طيب, seems to be clear for everyone. This is all for 5. I will inshallah post it on the YouTube, just 10 minutes, and I will stop now the recording.